Welcome to today's video, where we'll be exploring an interesting topic in Python programming. Have you ever found yourself wondering how to dynamically define a function signature for tools like pylance? Maybe you've encountered situations where you need to create functions on the fly, but struggle with defining their signature. If so, you're in luck, because today we'll be diving into this exact question and providing a detailed answer. In this video, we'll break down the concept of dynamic function signature definition, explore its importance, and provide a step-by-step explanation of how to achieve it. By the end of this discussion, you'll have a solid understanding of how to create flexible and dynamic functions in Python, which will undoubtedly elevate your programming skills. So let's start by understanding what we mean by dynamic function signature definition. In simple terms, a function signature refers to the combination of the function name, its parameters, and their respective data type. When we talk about defining the signature dynamically, we're referring to the ability to create or modify these components at runtime. To approach this problem, let's consider why we might need dynamic function signatures in the first place. One common use case is when working with data that has varying structures or schemas. In such scenarios, having the flexibility to adjust your functions according to the data can be incredibly powerful. Now, let's dive into how we can achieve this in Python. At its core, Python is a dynamically typed language, which means it doesn't enforce strict type definitions at compile time. This characteristic gives us the freedom to create and modify objects, including functions, during runtime. One approach to dynamic function signature definition involves using Python's built-in types module, particularly the function type class, dynamically. However, this method can become cumbersome for complex scenarios. A more elegant solution leverages Python's decorator syntax. By crafting a custom decorator, you can essentially wrap your original function with dynamic logic that adjusts its signature as needed. This not only makes your code cleaner, but also more reusable and maintainable. To illustrate this concept further, imagine you're building an OPI that needs to handle requests with varying parameters based on user input. Instead of writing multiple functions for each possible parameter combination, you could create a single function with a dynamic signature that adapts to the incoming request data. Before we conclude, let's quickly summarize the key points from our discussion. Understanding the concept of dynamic function signature definition is crucial for handling flexible and varying data structures in Python. Python's dynamic nature allows for runtime modifications, which can be leveraged for defining function signatures dynamically. A practical approach involves using custom decorators to adjust a function's parameters based on external factors. And that wraps up our exploration of how to dynamically define function signatures in Python. We hope this explanation has not only answered your question, but also provided valuable insights into the flexibility and capabilities of the Python programming language. If you have any further questions or topics you'd like us to cover, please don't hesitate to ask them in the comments below. Don't forget to like this video if it helped you, and consider subscribing for more content on Python and software development. Thanks for watching, and we look forward to engaging with you in the next video.